Imagine an announcement so significant that it forces aerospace giants in Connecticut and Ohio to hold emergency board meetings. Picture a Canadian facility, one that most people have never heard of, suddenly positioning itself as a direct threat to America's decades-long stranglehold on advanced jet engine technology. That's exactly what happened just moments ago. Rolls-Royce Montreal has officially unveiled a power plant breakthrough that shatters assumptions about who controls the future of aviation propulsion. This isn't another incremental upgrade or prototype that might see daylight in 10 years. This is a production-ready engine, backed by major international orders, designed to compete head-to-head with Pratt & Whitney and General Electric on their home turf. For the first time in a generation, the United States engine monopoly faces a credible challenger. It's coming from a factory just north of the border. To understand why this matters, why defense analysts and airline executives are suddenly paying attention to Montreal, you need to understand the history of jet engine dominance and the stranglehold that American manufacturers have maintained for over half a century. Jet engines aren't just components, they're the heartbeat of military and commercial aviation. Control the engine market and you control which countries can field modern fighter jets, which airlines can operate efficiently, and which nations can project power across oceans. Since the end of World War II, that control has rested firmly in American hands. Pratt & Whitney, based in Connecticut, pioneered turbine technology and powered everything from Cold War bombers to the F-15 Eagle. General Electric, headquartered in Ohio, dominated commercial aviation with the CFM International Partnership and military contracts spanning decades. Even when European competitors like Rolls-Royce in the UK or Snecmont in France tried to break in, they struggled to match American scale, funding, and political influence. The US government subsidized engine development through defense contracts. American Airlines, the largest customers in the world, bought American engines. Export controls restricted foreign access to cutting-edge turbine technology. It was a closed loop, reinforced by lobbying, national security arguments, and sheer market power. For decades, if you wanted a world-class jet engine, you had two real options, Pratt or GE, and both were American. That's the monopoly. That's what Rolls-Royce Montreal just challenged. Rolls-Royce as a brand carries weight. It's synonymous with luxury cars, British engineering excellence, and a legacy stretching back over a century. But what most people don't realize is that Rolls-Royce's aerospace division is entirely separate from the car company, which was sold off decades ago. The aerospace side, Rolls-Royce plc, is one of the world's leading manufacturers of aircraft engines, particularly for wide-body commercial jets and military applications. They power Boeing 787s, Airbus A350s, and a range of military aircraft across Europe and beyond. Yet, even with that pedigree, Rolls-Royce has always operated in the shadow of American dominance, especially in North America. Their engines were respected but niche, chosen by airlines seeking alternatives but never threatening the core market share of Pratt or GE. That's been the status quo until now. The Montreal facility has been quietly working on something that changes the equation entirely. Not a derivative of an existing British design, not a joint venture with an American partner. A clean sheet engine designed in Canada for the North American market, with performance specs that meet or exceed anything currently in production. Here's what we know about the engine. It's a high-bypass turbofan designed for next-generation narrow-body and regional aircraft. Think of the planes that dominate short to medium-haul routes, the Boeing 737 family, the Airbus A320 family, and emerging regional jets from manufacturers in Brazil, Canada, and China. These aircraft are the workhorses of global aviation. Billions of passengers fly on them every year. The engines that power them represent a multi-hundred-billion-dollar market over their life cycle. Currently, that market is split between CFM International, the joint venture between GE and Francis Safran, and Pratt & Whitney's geared turbofan. Both are excellent engines. Both are expensive. Both are American-controlled. Rolls-Royce Montreal's new engine offers a third option, and it's designed specifically to undercut the competition on cost while matching or beating them on efficiency, noise, and emissions. The engine features advanced materials, including ceramic matrix composites that can withstand higher temperatures, allowing for better fuel efficiency. It incorporates additive manufacturing, 3D printing for complex components, reducing weight and production costs. It uses a novel blade cooling system that extends component life and reduces maintenance intervals. And critically, it's designed for modularity. Airlines can swap out parts quickly, reducing downtime and operational disruptions. These aren't vague promises. Rolls-Royce Montreal has already completed certification testing with transport authorities in Canada, Europe, and is in final stages with the FAA in the United States. The timing of this announcement is no accident. The global aviation industry is in a transition moment. Airlines are retiring older, less efficient aircraft and ordering new fuel-efficient models to meet environmental regulations and reduce operating costs. Manufacturers like Airbus and Boeing are looking at next-generation designs for the 2030s and beyond. Regional jet makers, particularly Embraer in Brazil and Bombardier's successor programs, are seeking engine partners who can offer competitive pricing and flexibility. China's COMAC is trying to break into the global market with its C919 narrowbody. All of these players need engines. For years, they've been forced to choose between two suppliers, both American, both expensive, both with long lead times and complex political strings attached. Rolls-Royce Montreal's entry gives them leverage. It allows airlines and manufacturers to negotiate better terms with Pratt and GE by threatening to switch suppliers. It allows countries concerned about dependency on American technology to diversify their supply chains. And it allows Rolls-Royce to capture market share in segments where they've historically been weak. That's the business case. But the geopolitical implications are even bigger. Let's talk about what breaking the U.S. engine monopoly actually means. It means that Canada, a close American ally, but also a country with its own strategic interests, now possesses indigenous capability in one of the most critical defense technologies. Jet engines aren't just for airliners. They power fighter jets, transport aircraft, drones, and naval vessels. A country that can design and manufacture advanced turbines has options. It can build or upgrade its own military platforms without relying on foreign suppliers. It can offer engines to allies, creating diplomatic and economic relationships. It can resist pressure from larger powers because it controls a key input to military capability. For decades, Canada has been dependent on American engines for its CF-18 fighter jets and other military aircraft. That dependency gives Washington leverage in bilateral negotiations, trade disputes, and defense policy. With Rolls-Royce Montreal's breakthrough, Canada gains a degree of autonomy. It might not use this engine in fighters immediately, but the technology base is there. The engineers, the supply chains, the testing facilities, they're all in place now. That's a strategic asset. Now think about what this means for America's position. The United States has used engine technology as a tool of foreign policy for decades. Or when countries want to buy advanced fighters like the F-35, they're not just buying the airframe. They're buying access to Pratt & Whitney's F-135 engine, which requires ongoing support, spare parts, and upgrades that flow through American channels. That creates dependency. It ensures that buyers align with U.S. interests or risk losing access to maintenance and parts. It's a form of soft power, backed by hard industrial reality. But if alternatives emerge, that leverage weakens. If a country can buy a competitive engine from Canada or partner with Rolls-Royce Montreal to develop indigenous variants, they're less beholden to Washington. That shift doesn't happen overnight, but it starts with announcements like this one. Suddenly, monopolies aren't permanent. Suddenly, smaller nations have choices. Suddenly, the assumption that American technology is irreplaceable gets questioned. Europe is watching this closely, too. The European Union has long sought strategic autonomy, particularly in defense and critical technologies. They've invested heavily in Airbus to compete with Boeing. They've developed their own satellite navigation system, Galileo, to reduce reliance on American GPS. But in jet engines, they've been fragmented. Rolls-Royce is British, and post-Brexit, its relationship with the EU is complicated. Safran is French and partners with GE and CFM International, which limits its independence. Other European engine makers are smaller or focused on niche markets. Rolls-Royce Montreal's success could inspire a push for a truly European engine consortium, one that doesn't rely on American partnerships or British post-Brexit uncertainty. If Canada can do it, with a smaller industrial base and less government support than Europe, what's stopping the EU? That question is already being asked in Brussels, Paris, and Berlin. Expect discussions about increased funding for European aerospace research, streamlined certification processes, and trade policies that favor domestic engine producers. Asia presents another dimension. China has been desperately trying to develop indigenous jet engines for decades. Their fighters, the J-10, J-20, still rely heavily on Russian engines or are powered by Chinese copies of Russian designs. Those engines are less reliable, less efficient, and less powerful than Western equivalents. China's commercial aircraft, like the COMAC C919, initially used CFM International engines because Chinese alternatives weren't ready. Beijing views this as a critical vulnerability. They've poured billions into engine research through programs like the WS-10 and WS-15 for military jets, and the CJ-1000 for commercial aircraft. Progress has been slow. Metallurgy, blade design, and high-temperature materials are incredibly difficult to master. Rolls-Royce Montreal's announcement is both a threat and an opportunity for China. It's a threat because it shows that even without copying or stealing technology, a mid-sized facility in Canada can leapfrog them. It's an opportunity because Rolls-Royce might be willing to license technology, form joint ventures, or sell engines to Chinese customers in ways that American companies can't due to export restrictions. If China can access Rolls-Royce Montreal engines, even indirectly through partnerships or commercial sales, it narrows the gap with Western aviation. That's a nightmare scenario for U.S. defense planners. India is another country paying close attention. India operates a mix of Russian, French, and American military aircraft. Its commercial aviation market is one of the fastest growing in the world, with hundreds of aircraft orders pending. India has its own ambitions to build indigenous fighters like the Tejas program and regional jets, but engines have been a bottleneck. The Tejas uses an American GE F404 engine. Future variants need more powerful engines, and India has been negotiating with GE for technology transfer. Those negotiations are slow and politically sensitive. India doesn't want to be dependent on any single supplier, especially in a geopolitical environment where US-India relations, while improving, still have friction points. Rolls-Royce Montreal's engine gives India another option. They could negotiate a deal to license production, form a joint venture, or simply use it as leverage to extract better terms from GE. Either way, India's strategic calculus just got more complex, and that's exactly what they want. More options mean more autonomy. Let's zoom in on the technical details because that's where the real competition lives. Jet engine development is one of the hardest challenges in engineering. You're dealing with components that spin at tens of thousands of revolutions per minute, endure temperatures hotter than the surface of the sun, and must remain reliable over millions of flight hours. The materials science alone is staggering. Turbine blades are typically made from nickel-based superalloys designed to resist heat and stress. Rolls-Royce Montreal's engine uses advanced single-crystal blades and ceramic matrix composites in the hottest sections. These materials allow the engine to run hotter, which increases efficiency without sacrificing durability. They're also lighter, which improves overall aircraft performance. The manufacturing process involves additive techniques, 3D printing complex internal cooling channels that would be impossible to create with traditional casting. This reduces production costs and allows for rapid iteration during development. The result is an engine that's lighter, more fuel efficient, quieter, and cheaper to produce than competing designs. Those aren't marginal improvements. Industry insiders estimate a 10 to 15% efficiency gain over current generation engines and a 20% reduction in production costs. In an industry where margins are thin and fuel is a major expense, those numbers matter enormously. The noise reduction is particularly significant. Airports around the world face increasing pressure from communities concerned about aircraft noise. Regulations are tightening, especially in Europe and North America. Airlines that operate quieter aircraft can access more airports, fly at more times of day, and avoid noise-related fines or restrictions. Rolls-Royce Montreal's engine achieves lower noise levels through a combination of advanced fan blade design, acoustic liners in the nacelle, and optimized airflow management. It meets the strictest current noise standards and is designed to comply with anticipated future regulations. That's forward-thinking engineering. It means airlines that adopt this engine won't face obsolescence as rules change, protecting their investment and giving them operational flexibility. Pratt & Whitney's geared turbofan also emphasizes noise reduction, but it's more complex mechanically, which has led to maintenance issues in early deployments. Rolls-Royce Montreal's design avoids those pitfalls by using a more conventional architecture with advanced materials, striking a balance between innovation and reliability. Emissions are another battleground. Aviation contributes roughly 2 to 3% of global CO2 emissions, but that share is growing as air travel increases. The industry is committed to aggressive targets, including net zero carbon emissions, by 2050. Achieving that requires not just operational changes, but fundamentally more efficient engines. Rolls-Royce Montreal's engine delivers lower emissions per passenger mile through better fuel efficiency. It's also designed to run on sustainable aviation fuels, SAFs, which are derived from renewable sources and can reduce life cycle carbon emissions by up to 80%. Compatibility with SAFs is crucial because fuel infrastructure is shifting. Airlines and governments are investing in SAF production, and engines that can't handle these fuels will be at a disadvantage. By building SAF compatibility into the design from day one, Rolls-Royce Montreal is future-proofing its product. That's smart, and it's another selling point for airlines under pressure from regulators and customers to decarbonize. Now let's talk about the orders. An engine is only as good as the customers willing to buy it. Rolls-Royce Montreal announced that it has secured launch customers, including a major Canadian airline, a European low-cost carrier, and a regional jet manufacturer in Brazil. These aren't small players. The Canadian airline is likely WestJet or Air Canada, both of which operate large fleets and have significant influence in the industry. The European low-cost carrier could be Ryanair, EasyJet, or Wizz Air, all of which are constantly seeking ways to reduce operating costs. The Brazilian manufacturer is almost certainly Embraer, which is developing next-generation regional jets and needs a competitive engine partner. Together, these launch customers represent hundreds of aircraft and thousands of engines over the next decade. That's a multi-billion-dollar revenue stream. More importantly, it validates the product. Airlines and manufacturers don't commit to new engines lightly. They do extensive due diligence, testing, and risk assessment. The fact that major players are willing to bet on Rolls-Royce Montreal signals confidence in the technology and the company's ability to deliver. But orders are just the beginning. Rolls-Royce Montreal also announced partnerships with supply chain companies across North America and Europe. These partnerships are critical because jet engines aren't built in one factory. They require components from dozens of specialized suppliers, castings from metallurgy experts, electronics from avionics firms, software from systems integrators. By securing a diversified supply chain, Rolls-Royce Montreal insulates itself from disruptions and political pressure. If the US government tried to block exports of certain components, which they've done in the past, to competitors, Rolls-Royce Montreal has alternatives lined up. That's strategic redundancy. It's also a signal to customers that this engine program won't be derailed by geopolitics. Airlines hate uncertainty. They need to know that the engines they order will be delivered, supported, and upgraded over a 20 to 30-year life cycle. Rolls-Royce Montreal is checking all those boxes. The reaction from Pratt and Whitney and General Electric has been predictable. Publicly, they've issued statements welcoming competition and expressing confidence in their products. Privately, sources say both companies are scrambling. Emergency strategy meetings have been called. Pricing models are being revised. Lobbying efforts in Washington have intensified. Pratt and Whitney in particular is vulnerable. Their geared turbofan, while innovative, has faced reliability issues that have frustrated airlines. Unscheduled engine removals, extended maintenance downtime, and disputes over warranty coverage have damaged their reputation. Airlines have been complaining for years, but they've had no alternative. Now they do. Expect Pratt to offer aggressive pricing, extended warranties, and sweetened service packages to retain customers. Expect GE to emphasize their track record and scale, arguing that Rolls-Royce Montreal is unproven. Both will lobby the US government to tighten export controls, raise certification barriers, or otherwise hinder the new competitor. That's standard playbook. But it's harder to execute when the competitor is in Canada, a NATO ally and close trade partner, not China or Russia. The Canadian government's role in this cannot be understated. While Rolls-Royce Montreal is a private company, part of the British Rolls-Royce plc, it operates in Canada and benefits from Canadian industrial policy. The federal government has provided research grants, tax incentives, and support for aerospace development for decades. Quebec, where Montreal is located, has a particularly strong aerospace cluster, including Bombardier's legacy operations, CAE for flight simulators, and Pratt & Whitney Canada, ironically, for smaller engines. That ecosystem provided the talent, suppliers, and infrastructure that Rolls-Royce Montreal needed to develop this engine. The Canadian government also has a strategic interest in supporting alternatives to American monopolies. Canada is a trading nation, dependent on open markets and diversified partnerships. It's uncomfortable with over-reliance on any single country, even a close ally like the United States. Supporting Rolls-Royce Montreal aligns with Canada's broader goals of strategic autonomy, economic diversification, and technological sovereignty. Expect the Canadian government to champion this engine internationally, using diplomatic channels to promote it to allies and potential customers. What happens next depends on execution. Rolls-Royce Montreal has the design, the orders, and the backing. Now they need to deliver. They need to ramp up production, meet delivery schedules, and ensure that the engines perform as promised in real-world airline operations. Early teething problems are common with new engines, and how the company handles them will define its reputation. They also need to build a global service network. Airlines operate 24/7, and engine maintenance can't wait. Rolls-Royce Montreal will need service centers, spare parts depots, and technical support teams on every continent. That requires massive investment and logistical coordination. Pratt and Whitney and GE have spent decades building those networks. Rolls-Royce Montreal is starting from scratch in many markets. It's a challenge, but it's also an opportunity. They can design a service model optimized for the digital age, using predictive maintenance, remote diagnostics, and streamlined logistics. If they execute well, they'll set a new standard for customer support. The long-term implications are profound. If Rolls-Royce Montreal succeeds, it won't just break the US engine monopoly. It will inspire others. Expect increased investment in aerospace research outside the United States. Expect more countries to view engine development as a strategic priority. Expect new entrants from unexpected places, maybe South Korea, maybe Turkey, maybe a consortium of Southeast Asian nations. The monopoly era will give way to a multipolar landscape where customers have genuine choices, where innovation accelerates because competition forces it, and where no single country can wield engine technology as a tool of coercion. That's a healthier, more resilient global aviation industry. It's also a world where American dominance is no longer guaranteed. For Washington, that's uncomfortable. For everyone else, it's opportunity. But there's also a risk. Fragmentation can lead to inefficiency. Standards can diverge. Supply chains can become politicized. If every country tries to build its own engines for national pride, you could end up with dozens of mediocre products instead of a few excellent ones. The key is balance, enough competition to drive innovation and prevent monopolies, but enough collaboration to maintain safety standards, economies of scale, and interoperability. Rolls-Royce Montreal's approach, working within existing certification frameworks, partnering with established suppliers, serving international customers, strikes that balance. They're not reinventing aviation. They're offering a better option within the existing system. That's why this has a real chance of succeeding where other challengers have failed. For passengers, the benefits might not be immediately visible, but they're real. More efficient engines mean lower fuel costs, which can translate to cheaper tickets. Quieter engines mean less noise pollution near airports, improving quality of life for millions. Lower emissions mean a smaller environmental footprint for air travel. And more competition means airlines have better options, which ultimately benefits consumers through improved service, more routes, and greater choice. This isn't abstract geopolitics, it's practical, tangible progress driven by engineering excellence and strategic vision. That's the story of Rolls-Royce Montreal's engine breakthrough. It's a story about breaking monopolies, empowering choice, and proving that innovation doesn't belong to any one country or company. It's about a Canadian facility doing what many thought impossible, and doing it so well that giants are forced to take notice. The announcement just hours ago marks a turning point. The U.S. engine monopoly isn't completely broken yet, but the cracks are showing. Pratt and Whitney and General Electric will remain major players, but they're no longer the only game in town. Rolls-Royce Montreal has proven that with the right technology, the right partners, and the right timing, even the most entrenched industrial monopolies can be challenged. That's a lesson that resonates far beyond aviation. It applies to semiconductors, to batteries, to pharmaceuticals, to any industry where a few players dominate. Monopolies persist until someone is bold enough, skilled enough, and strategic enough to offer a better alternative. Rolls-Royce Montreal just did that. The world is watching to see what happens next. If this engine succeeds, it won't just power aircraft. It will power a new era of competition, innovation, and possibility in global aerospace, and that's something worth paying attention to. If this deep dive into Rolls-Royce Montreal's game-changing move got your engines running, you're exactly where you need to be. Our channel breaks down the technological breakthroughs, strategic maneuvers, and power shifts that mainstream outlets overlook. From aerospace innovations to defense industry disruptions, we bring you the stories that shape the future. Smash that like button, share this video with aviation enthusiasts and industry watchers, and subscribe so you never miss our next investigation. Your engagement fuels the research that uncovers these hidden stories. Until next time, keep questioning the official narrative and stay ahead of the curve.